The most expensive part of AI is not the answer it gives you. It is the electricity required to make that answer possible. Every time someone asks an AI model to write, code, summarize, draw, analyze, or think, it feels invisible. No smoke, no truck, no factory floor, just a clean text box and a fast answer. But behind that answer is a physical machine: servers, chips, cooling systems, land, water, electricity, construction crews, power contracts, substations, transmission lines, and in some cases, entire power plants. That is the business story most people miss. AI looks like software, but the AI boom is becoming one of the biggest infrastructure build-outs in the world. By one widely cited estimate from Goldman Sachs, a ChatGPT query needs nearly 10 times as much electricity as a Google search. But multiply that by millions of users, billions of prompts, corporate AI tools, image generation, coding assistance, and enterprise automation. Suddenly the numbers stop feeling digital. They become industrial. A simple question on a screen is connected to warehouses full of machines. Those machines need power every second of the day. They need to stay cool. They need backup systems. They need grid access. And they need to be built faster than almost any infrastructure system was designed to move. For years, the internet felt weightless. Photos lived in the cloud, videos streamed from nowhere, apps opened instantly. But the cloud was never actually a cloud. It was buildings. And now, AI is making those buildings bigger, denser, hotter, more expensive, and harder to power. This is why data centers have become the new gold rush. Not because they are beautiful, not because most people understand them, but because every major technology company now believes that whoever controls compute will control the future. And compute needs electricity, a lot of it. The International Energy Agency estimated the data centers consumed around 415 terawatt-hours of electricity in 2024. By 2030, its base case projects that number will more than double to around 945 terawatt-hours. The public sees AI tools. Investors see revenue potential. Tech companies see competitive advantage. But energy companies see something else: demand. A new kind of demand that does not sleep. A factory can close at night. A store can shut its doors, but a data center runs constantly. The servers keep working. The cooling systems keep running, and the power meter keeps spinning. That is why this business is so intense. A data center is not just a building with computers inside. It is a financial bet on future demand. A company spends billions today because it believes millions of people and businesses will keep using AI tomorrow. That tension is why the AI data center boom is fascinating. It looks like progress. It feels like the future. But underneath, it is a question every business eventually has to answer. Can the revenue grow fast enough to justify the infrastructure? And can the power grid handle the ambition? Because AI did not only create a software race, it created an electricity race. You can launch software globally in weeks. You cannot build transmission lines that fast. You cannot create skilled construction labor instantly. Conflict. AI companies are moving at internet speed. The power system moves at infrastructure speed. And those two timelines are colliding. The reason this collision matters is simple. AI data centers are not normal buildings. They are dense power users. Inside them are rows of servers packed with specialized chips designed to train and run AI models. Those chips create heat. Heat requires cooling. Cooling requires more electricity. This is why electricity has become one of the biggest bottlenecks in AI. Goldman Sachs research forecasts that global power demand from data centers could rise by as much as 165% by 2030 compared with 2023. That is not a small efficiency problem. That is a new industrial demand curve. A company can raise money. It can buy chips. It can hire engineers. But if it cannot get power, the plan slows down. That is why some data center developers are no longer just asking for grid connections. They are looking for their own energy solutions. Some are signing long-term power agreements. Some are looking at nuclear. Some are exploring natural gas. The clearest example is Microsoft's deal connected to 3 Mile Island. Constellation Energy agreed to restart Unit 1 at the Pennsylvania nuclear site and signed a long-term power purchase agreement to supply Microsoft's data center energy needs. When a company needs so much electricity that restarting nuclear capacity becomes part of the plan, the AI story is no longer just about software. It is about power. The message is clear. AI companies are starting to behave like energy companies, and that changes the business. Because once power becomes the bottleneck, the winners are not only the companies with the best software, the winners may also be the companies with the best access to electricity. That is why investors are watching data center operators, utilities, chip makers, construction firms, cooling companies, power equipment suppliers, and even landowners owners. The AI boom does not only create demand for apps, it creates demand for concrete, copper, transformers, turbine, transmission equipment, engineers. It looks like construction sites, electrical substations, industrial parks, rural land, heavy equipment, and utility board meeting. Big tech needs capacity. Cloud providers need capacity. AI startups need capacity. And everyone is racing to secure the same things: power, land, cooling, permits, and chips. By early 2025, the largest technology companies were preparing to spend hundreds of billions of dollars on AI infrastructure, data centers, chips, and compute. Deloitte reported that 8 hyperscalers expected to spend $371 billion in 2025 on AI data centers and computing resources. The Financial Times also reported that Amazon, Meta, Microsoft, and Alphabet had lined up more than $300 billion in AI spending for 2025. That is not a software budget. That is an infrastructure budget. But there is a problem. Local communities are not always excited. To a town, it may look like higher electricity demand, water pressure, noise, traffic. A facility may promise jobs during construction. A data center may promise tax revenue. But residents may ask whether the grid upgrades, water usage, and community disruption are worth it. Becomes emotional because the AI boom is not happening in a vacuum. And as the buildings grow, the tension grows with them. The people living near it are asking who pays for that future. If utilities need new substations, transmission lines, generation capacity, or backup systems, someone has to fund it. Sometimes companies pay directly. Sometimes utilities recover costs through rates. But the concern is simple. If big tech needs more electricity, will ordinary customers end up paying higher bills? That question has turned data centers from a technology story into a political story. And once a business becomes political, growth gets harder. Permits can slow down, local opposition can rise, communities can demand guarantees, and suddenly the AI gold rush has a very old-fashioned problem: permission. Not from users, not from investors, but from the physical world, the land, the grid, the water, the local community. That is the twist. AI may be digital, but its growth depends on things that are not digital at all. It shows that the future of technology may be limited by the oldest industries in the economy. The companies that win AI may not only be the ones with the smartest models, they may be the ones that secure the energy to run those models. This is why power has become strategic. A chip without power is just metal. An AI model without compute is just an idea waiting in line. That is why companies are willing to spend so much. If AI becomes the next platform shift, then compute capacity becomes leverage. The company that can train faster, serve more users, and lower the cost of inference may gain an advantage, but the bet is enormous. Data centers are expensive to build. Chips can become outdated. Energy prices can change. Regulators can interfere. And the business model still depends on AI demand turning into real revenue. That is the risk. But if the revenue does not grow as expected, the infrastructure can become a burden. That is why the AI data center boom has two possible futures. In the first future, AI becomes so useful that the infrastructure pays for itself. Businesses use AI constantly. Data centers become the factories of the digital economy. Power companies modernize the grid, and the physical build-out becomes the foundation of a new economic era. In the second future, the build-out runs ahead of demand. Companies overbuild, power costs rise, regulators tighten rules, and some projects that looked like the future start to look like stranded bets. Both futures are possible. AI data centers are not automatically a bubble, but they are not automatically safe either. They are a massive capital bet, a bet that people will keep using AI more often, for more tasks at higher value, for years. This is why the phrase, "the cloud," is misleading. Data centers are heavy. They need land, steel, power, water, cooling, workers, transformers, generators, permits, money. The cloud does not motivational float. It sits on the grid, and AI is making it heavier. That is the final lesson. Every technological revolution eventually meets a physical limit. Cars needed roads, smartphones needed chips, e-commerce needed warehouses, AI needs data centers, and data centers need power. So the next time AI gives an answer in a few seconds, remember what is behind it. Somewhere a server is running, a community is negotiating, and a power grid is being asked to carry more than it was built for. The answer on your screen may look effortless, because the future of AI may not belong only to whoever has the smartest model. It may belong to whoever can keep the lights on.